Hello everyone, and this is Manish Aswal. Today we are going to discuss the solutions of quiz 2 uh, of our MCQ questions. So these were the questions that were provided for day 2 of the quiz. So the very first question is, if the roots of the equation x square plus bx plus c are equal but opposite in sign, then, and there are four options, right? So just think of how will you solve it. So we have studied about sum of roots, product of roots, right? For quadratic equation, the same concept we can use because this is a quadratic equation, right? And there it it's like in quadratic equation, it should be mentioned that a is not equal to 0. But here a may or may not be 0. If a is 0, it is not a quadratic equation. And if a is not 0, then only it can be quadratic equation, because for quadratic the equation to be quadratic, it should have like second degree this term. But when a becomes 0, there will be no second degree term. So like be smart with this thing, catch these things, that whenever a is 0, this will lose the second degree term. So now let's move to ask the solution. We will be discussing this solution today. uh, so So we have this question. Question number 1. If the roots of the equation ax square plus bx plus c are 0 equal but opposite in sign, then. So I will also discuss the solution in very basic way, like in very detailed way, and also I will show you how to tackle it in trance in less than like a minute or couple of minutes, because you will have like very less time in exam to solve it, right? So when first let me talk it in detailed way, then I will show you the uh, tricky way, right? So that you can save time. So I will show from basic, so that even if you have forgot the concept, it will just uh, recall. So given equation ax square plus bx plus c equal to 0. So what I will do is dividing both side by a. When can I divide it by a? Only when a is not 0. If a is 0, we cannot divide, because in mathematics division by 0 is not permitted, right? So when I divide both side by a, when a is not equal to 0, it will give something like this, right? It will be something like this. So now, like when we divide both side by a, our equation will come this. This is the term. This is the equation we'll get, right? When we divide by both side by a, right? Now we want to make this equation in a form such that we can put it in this form, like a plus b square form. We wanted to make it, right? So for a plus b square, what it becomes in like I mean expanded form, ax square plus 2ab plus b square, right? So if we have already a plus a square plus 2ab plus b square, then we can of course write this one, na? Same thing we are going to do. We are going to do from we are going to do the transformation from this to this to this, right? So to make it in this thing, ax a square plus 2ab plus b square form, we have already x square term, right? So here we have bx times c. So this will behave like a. So it is like our a in this thing, right? So let me write it in capital. A plus b whole square is equal to a square plus 2ab plus b square, right? So this is our capital A, suppose. So our capital A is capital A square. Here we have capital A here, right? Now we need b. So in b, and also we need 2. So for 2 we will put 2 ourselves, and then in b the 2 can be like put there. So division by 2 is required to balance these two, right? So a square plus 2 ab we have. Now we need b square. So b, our capital B is what? B by 2a. So we'll have to add B square here to balance it, because this term we are introducing ourselves. So to balance it, we are also adding that equal term, that same term on the right side also, so that it is still balanced. And now we transpose this term to right side, right? So it was plus there, now it becomes minus. So it's clear, very basic mathematics. Just to recall, because many of you might have forgot it, so I'll just clear it so that you can understand the very basic concept, and then we can move ahead with the uh, concept required for this question, right? So now we can see that we have a square plus 2ab to ba we have, then we have b square, right? So we can write this in a plus b square, right? So that is what we have written. And in place of a, we have x, and in place of b, capital B, we have b by 2a. So b by 2a square. And this term, when you just square the all of the individual components, like we will have b square, and 2a square whole square is like 4a square and minus ca, right? And then you can see here, this can be like, when you take LCM and all and do this, this thing will come, right? So up to this I think okay, because 4a square and a square, LCM is 4a square and b minus and 4ac, like 4 will be like uh, the term from there, and then c. So now let's move ahead. Now we have x plus b by 2a square on the left here, right? So now if we take this square on the right side, we have to put plus minus, we have to put plus minus under root, right? So plus minus under root we got here, plus minus sign. Plus minus sign means because at one time we have to take plus sign, the result with plus sign, and the other time we have to take the result with minus sign. Now when you transpose this term to right, it becomes minus, because here it is plus. So we have the final value x equal to minus b by 2a plus minus uh, under root b square minus 4ac whole under 2a, right? So further, when you solve this, we have one time you take this plus sign, right? One time take plus sign, other time you, and another time you take minus sign. So these two will give both of these terms, right? So these are the two values of x, or in this polynomial form we say the roots of the this quadratic equation, right? So suppose if these roots are alpha and beta, let alpha and beta be the roots. So one value we can say it as alpha, another value we can say it as beta. So when we sum them, what it will be? Sum of roots, because alpha and beta are roots. So when you sum alpha and beta, it is like sum of roots. So sum of roots, so we are putting summing this value, this term, this whole term, and this whole term. So when you sum them, and you can see that these two have like negative same value but negative signs. So these square root things will get cancelled on both, from both of these terms. Then we are left with only minus 2b by 2a, and 2 again gets cancelled. Then we have sum of roots is equal to minus b by a. So that is like alpha plus beta is also known as sum of roots, which I have written here, right? So I think everyone should be clear with this. Sum of roots is equal to minus b by a when the equation is what? Our quadratic equation was ax square plus bx plus c equal to 0. For this equation, suppose x have our x, if x has value roots, that is alpha and beta, then alpha plus beta will be this minus b by a. Clear to everyone? I hope it is clear to everyone. Similarly, just this is not required in this question, but still also product of roots. Product of roots, what it will be? Alpha times beta. That is product of roots. And when you multiply these both, na, you will get c by a. So remember this formula. Just try multiplying this, because I have already derived this thing alpha and beta value here. And when you multiply both, you'll get c by a. And c by a, what are the c and a? This is a c, and this is the a. Coefficient of x square is a, and that constant term is our c, right? So we derived that sum of root thing. This was not required. The derivation was not required here, but still many of you might have forgot uh, that how the sum of roots is equal to minus b by a. So I just showed it right now. In question what we are given, just read it again. If the roots of the equation ax square plus bx plus c are equal but opposite in sign. So if we are letting uh, alpha and beta as these roots of this equation, so alpha and beta are equal in magnitude but opposite in sign, right? So that means alpha equal to what? Minus beta. According to the equation, given that the roots are equal but opposite in magnitude. So alpha equal to minus beta. And when you transpose minus beta on the left side, what we get? Alpha plus beta equal to 0. So, and we have already got the formula. We have already formula that like in exams, in France exam, you can directly use it. You don't need to show the derivation. Just for your understanding, I have derived this all. So you have to remember that sum of roots, that is alpha plus beta equal to minus b by a. So again from the questions, what we are given that this sum of roots and like sum of roots value is 0. So that means minus b by a value is 0. So when you transpose a on the right side, remember a is not equal to 0, right? So anyway, when you multiply 0 into a, that is it gives b equal to 0. So this will be our answer, option B, right? B equal to 0 is in option B, you can see. So this is a very long like solution which you never ever do in entrance exam. Just note it. You don't have to do this long got solution. We'll have to do, we'll use another technique, shortcut technique, by just remembering this formula, sum of roots formula minus b by a, and this sum of product whenever it comes for this question, sum of roots is only required, right? So you can see, you can also reject some options. If the roots of the equation x square plus bx square are equal, so for two roots, I mean equal roots, it should have to be like quadratic equation, right? So quadratic, if the equation is quadratic, a cannot be 0. A cannot be 0, right? For quadratic equation, a cannot be 0. So this option is already rejected. I hope everyone is understanding. Also, let me try with this option b equal to 0. When b equal to 0, try with options. Like we are going to play with options. The detailed solution you don't need to do in exam. In exam, play with options, right? So a equal to 0, when you put, the equation will be bx plus c, bx plus c. So this is not a quadratic equation. Bx plus c equal to 0 is not a quadratic equation. This is equation of like a straight line. It will represent only one line. So, but it is saying, the question is saying roots. It is saying plural. So a cannot be 0, right? Because when a is 0, there will be a value of x will be only 1. Now when you put b equal to 0, the equation will be ax square plus c equal to 0. So what will be the value of x? X will be minus c by a, right? x square will be minus c by a. Then we have x equal to plus minus under root minus c by a. So c, it will have two roots, minus c by a under root minus c by a minus under root minus c by a, right? So this is possible, b is possible, but still we can check, we have to reject c and d also, option c and d. So when c is 0, you can put it and see that the roots will not come to be like up equal and opposite. Let me put, when you put c equal to 0, right? So when you put c equal to 0, what it will get? You will get x square plus bx equal to 0. So from this we get that x is taken common, ax plus b equal to 0. So in this you can see one root is 0 and another root is, one root is 0 and another root is minus b by a. So these are not equal in magnitude. So this option is also rejected, right? and this is little complex, and still already you got one satisfied like option. So your option is this right answer. So in entrance exam, just play with the option. And this is given roots of the equation. So a cannot be 0 for quadratic equation. The equation to be quadratic, right? So a is rejected. When you put c, the roots cannot be equal in that case. So c is also rejected. And among this and this, just don't try experimenting with this first. Try this, and if this is satisfying, like it will be a answer. So if I were in your place, I would apply this approach, right? I won't do this detailed calculation. Never ever I will do, because in entrance exam, no one is going to see your rough sheet. They want the answer only, like among 4 or 5 options, what whichever is given, they want you to choose among, select among them the correct one, right? So just play with option in such cases. So now we'll move to question number 2 for quiz 2. So this was our question number 2, right? So in question number 2 also, I will show detailed solution, but let me say in this also, in the question is integration question, right? So you can play with options. When you do the derivative of options, so like derivative and integration are like inverse of each other, na? When you like given a derivative, when you are given a term and you make derivative and again do integration, the original term will come back, right? Like for example, if we have x to the power n, if you do it derivative, calculate the derivative with respect to x, what will you get? N x to the power n minus 1, right? But and when you do integration of this one, na, so n x to the power n minus 1 dx, you will, what will you get? You'll get x plus c, right? Xn plus c, x to the power n plus c. So we already got original term, and this constant is like constant of integration, because like constant gets 0 na while calculating derivative. So maybe sometime it is not 0, so we'll have to put when we are doing integration. So anyway, in entrance exam, what you do is play with options, do derivative of options, whichever will give this term, so that will be your answer. And also the next trick is like the tips tips for this question. First tip is play with options. Play with options, right? Next tip is uh, choose simple option first, right? Simple option first. See, the option number 1 is very complex, though it will be the answer, but don't start with this. Start with simple something like this: C, or like we can say B, D. In this way, you will start. Uh, and in case sometime it may be the option is B, or option is C, or option is D. In this case, it is A. But still play with this. If these all three, and also when you are playing with options, don't play with all 4. You have to test only 3. If 3 are already rejected, the fourth one should be for sure. If the options are right, the fourth one for sure will be your answer, right? So again, think of this wisely. You don't need to check all of the options. You have to, if there are 4 options, you will have to check uh, only 3 options. So if there are 5 options, you have to check only 4 options, because if 4 are already rejected, fifth one will be our answer. So if there are n options, you have to play with only n minus 1 option. You have to test it, right? You can do the testing of other options also, but that will be like just waste of time. So I have shown the detailed calculation here. First of all, we recall the derivative of sine inverse x. What is the derivative of sine inverse x? 1 by under root 1 minus x square. So this will be done, this question can be done by, many of you can remember that this is like integration question, and this can be done by substituting method, right? We have to substitute the term y equal to sine inverse x, then calculate the derivative of y, that is dy by dx equal to what it will be, dy by dx. This on the left side thing will be dy by dx, then right side thing will be what, derivative of sine inverse x, that is 1 by under root 1 minus x square. So this dy, what this term, what it will be? It will be dy equal to, we transpose this dx term to right, so dy will be dx by under root 1 minus x square. So this can be substituted in the original equation we had. This thing you can see, this can be substituted to dy, right? Dy. Again from this you can see that y equal to sine inverse x. So when you transpose this sine to on the right, what it will be? X equal to sine y. Got it? This is a very simple thing we people have already done. Just to recall in case you have forgot it, so we are doing revision kind of thing. So now when you substitute these both things, we have the integration I mean this original question, I equal to sine y times y times dy. Now in this case, what we used to do in our like mathematics course in our 11th 12th, we were using integration by part, right? So I let once check it, like what are these all things stand for. As far as I remember, I have written these all. So like for I let na, we have I let. So what we can do is once Google it and you get formula I let, what are ILAT stands for. So I think I should stand for integration. No, not in inverse function. L for logarithmic function, and then we have like LA, we have LATE, algebraic function. We have inverse function, algebraic functions, logarithmic function, then trigonometric exponent function, right? So this A here is algebraic function. So priority should be given to, there will, if there are two functions na, f1 f2 dx, so your f1 should be like priority order should be this way. First priority should be given to for f1, the first priority should be given to inverse functions, then to logarithmic functions, then to algebraic functions, then to trigonometric functions, then to exponential functions. So I hope you can recall it. Now we have this all integration by parts thing, y sine y dy minus this, just go through this, so minus y this thing and substituting back. Now when you do this integration and all, so you have minus final answer as minus y cos y plus sine y and plus c, where c is what? Constant of integration. Now substituting back the value of y, what will you get? You will get this one. Minus y means sine inverse x, and again cos y, then cos, and in angle term what it will be? Sine inverse x plus sine y, what it was, like we had put y equal to sine x, sine inverse x na, so what it will be? uh, X equal to sine y, right? So that is what we have written here. So finally after integration we got this. So this is like a long way, you don't need to do this way in entrance. You can do it if you have sufficient time, but still that's not the logical thing you are doing. That you should be smart enough not to do whole of the integration. If there are some simple options given there na, you can play with the options and reject those simple options, or in case if the simple option itself is the answer, you are lucky enough, otherwise fine, and you can just reject those simple options, and then uh, if the three options are already rejected, the fourth one for sure should be your answer, right? So in trans exam, play with the options, try calculating the derivative of simple options first. So I have shown some calculations here, that you had option number C, we had na x square by 2 plus c. So when you do its derivative, it will be x. So this can be simply rejected na, because we have very complex thing and this x is coming, so this is rejected, right? Now play with option B, option D. Option D is also simple option. So when you are playing with option D, you are getting this. So this is also not your question, na? So this is also rejected. Again, when you play with option B, you are getting something like this, and you don't need to. So I've shown each and every step here for your understanding. You don't need to do these all, right? When you are doing it, you can directly do from here to here, here to here, right? And in rough sheet, do you need to copy the questions? No, just start from this step. Start from this step to save time, right? Just think it that you are doing something here. This thing, derivative of cos sine inverse x, right, plus c we had now plus c, okay, and this. So just think is you don't need to write this one left term. Just start with this, and then you are done. So in this way, I used to save time, and almost every people like who are cracking with good rank are doing these same things. In drop sheet, you don't need to write or copy the questions. Yeah, but don't miss the steps also. Be sure about that also. I hope that's like okay. We can move with another question. What was the conclusion? That if there are integration questions and they are complex terms or even simple terms also, play with options, because among the four options, if there are right answers, for sure when you do the derivative of those derivative of the right answer, your original question should come, right? So even if you don't know integration or you have forgot somewhere, you can do the integration questions with the options. That's the like benefit of or positive aspect of this MCQ exams. So now moving ahead, we have this question number 3. Let z equal to this iota plus root 2 whole to the power 10. Then calculate the modulus or magnitude of absolute value of z. So what is z here? Z is a complex number, right? So we have complex number. Suppose like this in question, it is already given z. So to not to mess up with the notation, I'm mentioning a simple this complex number z1. So z1 equal to what we have in complex number in rectangular form? We have z1 equal to, like, a complex number can be represented as in rectangular form as a plus iota times what b, right? So a plus ib, right? And the same thing can be written in polar form as polar form. What do you write to a plus ib? R comma theta. This thing can be written as a comma b also, and r comma theta also we need to write na. So that r comma theta in exponential form can be written as this thing. Just note it. This is the very trick. This is the like clue of this question. The answer can be obtained from here itself, right? In entrance exam, what we have to do? We have to calculate r and theta, and then if you just convert this into polar form, na, you are done with the solution. So for example, like let me first talk how r and theta are calculated in detail, then we can just do in like less than 10 second or like 30 second, I can say. So first remember that complex number can be represented in rectangular form as a plus iota, that is times b, and the same thing can be written in r theta terms, where we'll calculate r and theta accordingly shown here. So what is the value of r? R is under root of a square plus b square. This a is a real part and b is imaginary part of that complex number z1. So this r is known as what? Absolute value of absolute value. R is known as absolute value or modulus of this z1, that is our complex number a plus ib. So when you do write it in this thing, complex plane, we have this is like our real plane, real axis. This is imaginary axis. So a is our real component na, and b is our imaginary component. So when you plot it, I will get something like this. A line you will get for this complex number. A comma b is that point. So this is the complex number like notation, I mean representation in complex plane. So same thing, if you convert it in polar form, na, we will have to write into r comma theta. A comma b can be written into r comma theta in polar form, where r is what? Your absolute value, and theta is the direction from positive x-axis, right? Remember, positive x-axis. Theta is the direction from positive x-axis, not just x-axis. So from this triangle OPN, from OPN triangle, you can see that from OPN triangle, you can see that what we have, cos theta equal to what, this PN by cos theta equal to, sorry, ON by what, OP, that is our hypotenuse. ON is our base, PN is our air, perpendicular, right? So this should be like perpendicular. So cos theta equal to ON by OP, that is A by R. So that is when you transpose it, na, you will get A equal to R cos theta. Similarly, sin theta equal to what? Sin theta equal to this B. This PN is what? B. So B by R, that is R is a hypotenuse. So when you transpose this thing R to this side, so our B equal to R sin theta. So just this was not necessary in for entrance exam, but just to recall in case if you have forgot, I just showed it, right? So we got A and B. So A and B, when you have what, R theta and R and theta, but we need this time we need reverse thing, right? So what we have to do is we can see that value of A is this R theta, value of B is R sin theta, value of A is R cos theta, value of B is R sin theta. So when you do a square and then sum these both values, what we get, A square plus B square equal to this thing we'll get. And we know that sin square theta plus cos square theta equal to what, 1, na? Sin square theta plus cos square theta is equal to what, 1, right? So this 1 R square times 1, it will be 1 itself. So when you have this R, and we are not taking your what, plus minus y, we are not taking this. Why? Because this is just a value. We don't need magnitude here. Magnitude will be reflected by what, tan theta, that is theta, right? So this is simply a numerical value. R is simply a numerical value, so we are not considering here signs. So R is equal to what, when you have A and B, R will be what, sum of squares, root of sum of squares, right? So in this case, the question is asked that what the question is asked, if this is a complex number, so the this absolute value of the complex number, right, or modulus of the complex value, I mean complex number. So our question was Z equal to I, that is our iota. Remember, don't get confused. Don't write this as this coefficient of I as A. Don't write it. It is just given for your confusion thing. And similarly, don't write it B. We have A this one and B this one. Not of these A and B are not like simply of Z. It is like some other complex number, that is you can say for example here Z1, because Z is power of this Z1. If you write Z1 equal to A plus IB, that is root 2 plus I, right? So what we have, Z is equal to Z1 to the power 10, right now? So suppose let Z1 equal to I plus root 2, we let it, then we have, what is the A? I showed A here. So A equal to what, root 2. B, coefficient of that is iota, that is 1 here. We have 1 na, so B is 1. Now when you calculate A, R, so from this formula you can see R will be what, under root of A square plus B square. So under root of A square plus B square, that is we are doing here, right? Now when you do this all, we'll have like root 5. So they have what they have asked, the this thing, absolute value of Z. So what will be absolute value of Z? Z will be like, Z will be in exponential form or polar form. You can say it will be like this. So absolute value of Z will be what? And Z will be R, na, R. But this R is not of Z. This is of Z1. Remember, don't get confused. Otherwise, many people will give option, if there are options with value root 5, they will tick this, but don't do that. This R is absolute value of Z1, not of Z. So z1 we have na, z1 to the power 10. So we write r e to the power I theta whole what 10. So it is r to the power 10 e to the power uh, 10 theta 10 I theta, right? 10 I or theta I. You can write this as 10 theta I. So this is the absolute value. This is the absolute value of what? Z. So r to the power 10, that is root 5 to the power 10. And in case for this question, direction is not needed, but in case you needed direction, na, you could calculate this one. Theta equal to, or argument also they say for complex number, theta equal to tan inverse b by a, and b and by a value you are given. So this thing all calculation I have done. Right. So your option will not be root 5, rather it will be root 5 is the absolute value of what? Z1. That is within that bracket, not of root. There we have power raised to 10. Z is power raised to 10 of the root 2 plus 1, I plus root 2 complex number we have na, I plus root 2. So that is Z is the question. Z is in the question. Z the complex number is iota plus root 2. That is a complex number whole to the power 10. So that's the Z. So we already got our answer, that is root 5 to the power 10. So in many of the uh, syllabus, they have given this thing. A complex number is given by a comma b, that is rectangular form notation, polar form notation r comma theta. But sometimes we are not familiar that this r theta can be also written as r e to the power I theta. So just note it down so that you don't miss it, right? Because when you are given a complex number is written as r e to the power I theta, when you are raising it with power n, what you can write? R n e to the power I n theta. Simple. Because for exponential, power gets just multiplied with the already existing exponent, na? Right? So this was the catch here, this formula. This is the very important formula for discussion. Just note it down. So if you are known with this, you can just do it in like less than a minute. R you have to calculate with the inside one, and that r to the power 10 will be your answer. So inside one, this complex number will be I plus root 2, that will have a value of r as root 5, and that raised to power 10 will be your absolute value of your given complex number Z. Yeah, so that's it. Now let's move to question number 4. That is our fourth question for today. So this was the question: the derivative of x to the power x is. So for this, what we do is, in exam, don't do these all formalities, right? Just to make you clear, I am doing it as an we do in theoretical exam. Otherwise, in MCQ exam or entrance exam, you don't need to show a step. Even if you are giving your blank rough sheet, that's fine. Your whatever you just select in your computer na, for computer based test, that will be your that evaluation will be done on the basis of same. Even if you have done all the solutions in your rough sheet, but you have not selected proper correct answer in the computer, you will not get any marks. So, and try to, in while practicing home, you can do as many steps, but still try to skip steps for entrance exam. Initially just practice with all the steps, but with more and more practice, just try skipping steps so that you can save time. So in entrance exam, don't do these all formalities. Simply start with this. uh, like you have already given there we are going to find the derivative of x to the power x na. So just suppose you have x to the power x, then you are writing log x log y equal to, you are taking log on both sides, then you are taking what? You can directly write this log x log y. So there are many steps you can save, just two line of things, then you are like going to proceed with derivative. So I've done it here as theoretical exam. So let y equal to x to the power x, taking log on both sides, what we get? Log y is equal to log of x raised to the power x, x raised to x. So we have one formula na in log, that log b to the power a. If we have, what it will be? It will be a log b. So this is log formula, you just recall it. So this x is taken here, here. So this is what I have done. Just the power thing I have been as coefficient. Now differentiating with respect to x, you all know differentiation. So log, the differentiation of log x is what? 1 by x. So that I have written on the right, you can see here. So differentiation of log y will be 1 by y, and then to balance that is we are using chain rule here, dy by dx. Then similarly this you have to use product rule. Derivative of what? U v is what? U dv by dx plus v du by dx. So remember this product rule also, that we have applied for this the term on right. So derivative of log x, we have taken, we are taking x as u, x as u, log x as v. So u will be x, then we have dv by dx means d log x by dx, that is 1 by x. Then we are taking again v means log x, v we have written. Then we are calculating dx by dx, dx by dx is 1. So from this, don't, many people will say this will be our answer, log x plus 1. Don't do this mistake. You have this y term, you need to transpose it on the right. So dy by dx equal to y terms, that is 1 plus log x. So y in answer there is no y, we have introduced y ourselves. So what was the y we supposed? Y equal to x to the power x. So that you need to substitute back, and when you substitute back, you get this x to the power x 1 plus log x. So this is our option B is the answer, right? So in entrance exam, you can simply save time for this question by just skipping a step. What you will do is, in entrance exam, skip steps also. Skip steps. Don't write these all what you are doing. Whatever instruction we used to write, na. So don't write those in entrance exam. Just start with y equal to, even you don't need to write late word. Just write y equal to x to the power x. Then you don't have formula for this thing, na, exponential derivation. So what you can do is just take it, make it as a like coefficient by taking log. So log y equal to what? X log x. So simply if I were in your place, what I would do is, I'll suppose y equal to x to the power x, then I will take log on both sides. In mind only, I'll think that I have written this step, right? So log y equal to x log x, then do derivative. When you do derivative with respect to x, what you will get? You'll get 1 by y times dy by dx equal to, here what we will get? First you will do derivative of this log x term, then x into 1 by x plus log x times 1. So finally, even now next step I don't need to write. Simply I'll think in mind only. My required question was to calculate dy by dx. So dy by dx will be what? This y transposed to this side. So that is y times 1 plus what? Log x. So again, you don't need to write y value also here. Just think what you whatever you have substituted supposed or late, that will have to be substituted. So finally answer is done in how many steps? One step. See, I'll count how many steps we need. First step was this, second step was this, third step was this. So in 3 steps we are done, right? Even if we have to solve, we are done in 3 steps. So this is the catch up in trans exam. This is the trick and tips. Otherwise, like guessing will not work, right? Guessing will not work. And even don't you cannot proceed with options in this case, because when you are doing integration you cannot do, right? Integration will be like tougher than differentiation. So for this question you have to do from question itself, but skip with the rough steps or like calculation things. Just think in mind only, write the necessary thing only. So yeah, uh, for today I hope everything was clear to you people. And we'll again come with our solution for day 3. So let me just share with you the questions for our day 3 quiz, which we have already released today. So these were the questions for day 3. What the hell is going in here? Just note it down that these were the question in case if you are not uh, like not familiar with where we are posting. So this is the questions we had shared on our Facebook page. Our Facebook page name is IOE Pulchok in Rans Help Desk. So please follow our page and get daily questions and solve it and practice more and more. And we'll also post detailed solution on this YouTube channel, and also show you tricks and how to tackle it in less time. But yeah, remember, you should be clear with the basic and understanding things. Otherwise, how can you proceed with the complex things? So basics should be first clear, then do easy questions, medium questions, then only move to complex questions. And in case you are appearing for IIA Pulso campus in trans exam, even if you are not able to solve complex questions, there are very much probability that you will get selected in case you are like able to solve medium and like easy level questions. Hope to see you at Pulso campus. Thank you. Bye.